So here is the next problem, that is problem of the day. Okay, that is largest divisible subset. Okay, so this is the question. Okay, medium question. Okay, so I have written here, basically I have screenshotted the question. You can see the what the question is saying. Let's just understand by example. Okay, so or you can read the question that we have given a positive integer nums array. Okay, in which numbers are there, and we have to return the largest subset, that is answer. Okay, such that every pair, so I and j, this element in this subset satisfied this condition. Okay, these are two conditions. It can satisfy any of them. Okay, so if there are multiple solutions, return any of them. Okay, so simply we have to check for every possible pair that makes this, or you can say we have to make every possible subset. Okay, so let's just understand the question a little bit more. So if I make the array that is given, so simply here let's just understand what the question wants to say and what we have to return the answer. Okay, so this is the question. Okay, this is the array that is simply given in the example. So what we have to do, basically we have to check if like if we say this is here is I, okay, and here is j. Okay, let's just see that here is I and here is j. Okay, so if you just see, if we just take this number, that is 1 and 2, so if you see that 1 is divisible by 2. Okay, so 1 is divisible by 2. Okay, and 2 basically no, 1 is not, basically 2 is divisible by 1. Okay, so we can say that 2 percent 1, that is simply remainder will be 0. Okay, but 1 is not divisible by 2. Okay, if I just write this reverse, okay, that is 1 percent 2 will be equals to simply 1. Okay, so simply if you see remainder in this case is 1, in this case is 0, but if this is valid, and you can simply say see here that any of this is valid, that is answer I could be divisible by j, and answer j could be divisible by answer of I, that is both is valid. If 2 was here first and 1 was here, then it could be possible. Okay, any of these should be valid. Okay, so simply in this case this is valid. So if you just check for 1 and 3, that is also subset, so simply it will also be a valid condition. Okay, then you can see 2 and 3, that is not a valid. Okay, 3 is not divisible by 2. Okay, so simply it is not divisible. Okay, 1 and 3 and 1 and 2 are the possible solution in this example. So you can see here also, that is 1 2 is the solution, and here it is written 1 3 is also accepted. Okay, that is the longest subset that you can return, because if you choose all three, then this is not possible. Okay, 1 and 2 is divisible, but 2 and 3 is not divisible, so simply this is not possible. So let's just take this second example for better understanding the approach what we can do. Okay, so this is the next example. If you see one thing, that is here, what is the thing that I want to basically explain you, that if 2 is divisible by 1, that is these two are the solution. Okay, these two are framing solution, and then 4 is divisible by, that is 2 divides 4, that is its next number, and then 4 divides 8. Okay, so one thing you can see that if 4 divides 8, so these two are the solution. Well, basically these two are in the solution, and 2 divided by 4, then you can see 2 also divides the 8. Okay, if 4 divides the 8 and 2 divides the 4, then according to math 2 is also the factor of 8. Okay, so you just need not to check 2 to 8. Okay, you can simply say if 2 divides the 4, if 4 divides the 8, then we can simply say 2 divides 8 also. Okay, so simply if this and this these two are the valid answer, and these two are the valid answer, that we can simply say this whole 3 array is the valid answer. And if it is 1, then simply say 1 divides, if 1 divides the 2, then simply its whole is the valid answer, without any, basically it's for checking every pair. Okay, So that's why here both, basically all 4 are the valid answer. So simply 1 divides the 2, 2 divides the 4, and 4 divides the 8. So simply these all will divide the other also because they are factors. Okay, so this is how we are going to approach it. Let's just take one more example. Okay, so here's the one more example. You can see, so if you start from here, that is 1 divides the 2. Okay, so it is a valid. Then you will see 2 does not divide the 5, so the pair is completed. So this 1 to 5 can't be the answer. So simply then you will check for 1 to 5, then it is a valid answer. Then it will simply check for 5 to 15, that is simply divided. Then 15 to 45, that is also a factor. Then simply you can return 1, that is 1, 5 and 15. Okay, 15, 45, where excluding 2. These 4 will be the answer simply. So simply you can say that we have to check for like 2 things. Okay, that is the index, okay, and the previous. Okay, because we need previous. You got the thing why we need previous, because if we are checking for like here 2 is divided by 4, and then we are checking for 4 divided by 8, that we need that 2 that is previous. Okay, 2 was divided by 4. Okay, so simply we can include that. Okay, so simply we need 2 things. So let's just make it big. Okay, so one thing is that this is a DP problem. This is not a greedy, because if you just think of this example, if we start from this like 1, that is simply 1, and if we start from then you will simply say 1 is divided by 2, then simply it would be right. Okay, then you would say that 2 is not divided by 5. Okay, 2 is not divided by 5. Okay, simply it is not the answer. Okay, so simply then it will move on 5 to 15. Okay, so simply it will say 5 is divided by 15. Then simply it will say 15 is divided by 45. Basically 45 is divided by 15. Then it will simply say it is the answer, and 1 will also include it. Okay, so simply it will return 1, 15 and 5 also. Okay, so simply 45. Okay, so simply this will be the return the answer. Okay, so you need the previous one. Okay, so if we are checking 5 for 15, then you need the 1 also. Okay, if it is divided, then we will include in the this previous also. So simply you can say this is how we are doing. Okay, so let's just see how we are pushing the answer. So this is the 2 things we are needing: I, that is index, and previous, that is simply the previous number which we have checked. Okay, so simply the 2 things that we will. So this is basically the DP problem. You know that this is not a greedy problem. I have told you that if you got this 2 answer, that is for at first you will get only these 2, that is 2 is divided by 1, and then 5 is not divided by 2. Then you in greedy, then it can simply return this answer, but not, we have to find the largest. So that's why we have to check every possible solution. So that's why it's not a greedy, it's a DP problem. We have to check every solution. Then we are checking, that is for first, that is the first index. We can simply say we can initialize this with 0 index. Okay, and the value is 1. Okay, so simply it will come on first index, that is here. So it will simply say index, that is will be simply 1. Okay, and the previous number is that is 1 also. Okay, so simply it will choose 1 or not choose 1. Okay, simply pick and non-pick. So if it will not choose 1, then okay, so simply it will include 0, not 0 basically, and not anything. Okay, so simply it will not choose anything, then simply it will only include index. Okay, so let me just write. Okay, so it will not, if it will not choose anything, that it will simply include so the array would be empty. Okay, so if I just write, okay, array will be empty, and here the array would be simply, if I just write array would be simply included 1. Okay, so simply it will be included 1. Okay, so here I would be 1 and previous would be 1. Okay, so simply we will move further. Okay, because you know that this will not give answer, we just don't move forward because we have not included the 1, so it will be in the basically answer. So then we will move forward, then we will go on 2, then we will include 2, then we will not include 2, then we will go on 5, from both we will go from 2 to 5, then simply it will say it will not form the answer. Then we will go from here where we have not included the 2, 1 to 5, then simply we on 15, then 45. Okay, so simply this is how this approach will work. Okay, so let me just write the code, you will understand there from there. Okay, let me just clean it. Okay, so let me just write the code, so you will basically understood. Okay, so let me just okay, so here's the code. Okay, so let me just make it small. Okay, so I've written whole code here, so it's not basically not printed very good, but I will explain you the code. Okay, so for what we are doing basically, so first this is the main basically function. Okay, so first we will sort it. Okay, so we basically, why we are sorting, one thing I have not told you, because if you know we will sort it, then simply we will get at last the largest number. We can simply check it by dividing. Okay, we know that the largest number, that is here, is 45. If it is divisible by this previous, then we can simply say it is divisible. Okay, now all the, if then we will check for all the previous, then we know that if 15 divides 5 and 5 divides 15, then we know that 5 also divides 15, 45, sorry. Okay, so simply we need to sort the, okay, then we will simply sort the array. Basically it is sorted, then we but we will check it. Okay, we will just sort that, then we will take the n, then we will simply take the cache vector, that is simply take the n, that is the size, and then it will simply take the 2D array of n plus 1. Okay, then this dfs is the main function that will simply recursively call. Okay, so base case is this, I equals to num dot size. If it is at the last position, that is I is at the, then simply it will return the empty array. Okay, and every time it will check if cache of I and previous index plus 1. Okay, basically it is, if it is not empty, okay, basically it's saying if it is not empty, then we will return the this cache. This is like memorization, you know that. Okay, it simply return the value if it is present previous. Okay, it doesn't track every time the same thing. Okay, then we will return the store the result. Okay, at dfs I plus 1. This is the skip condition. Okay, we will simply skip the next element, and these are the same. Okay, then if we are not skipping, okay, if this is not, we are not skipping, then simply we will say if the previous index is -1. Okay, if we are at first, basically first time, or this is divisible, we will check for by divisible this nums previous index. Okay, this previous index divides the current index, and it divides, then we will simply store the temporary in the this basically this number, and then we will simply check for the next iteration. Okay, that is recursively call the. Okay, then we will simply insert the temp variable. Okay, then simply we will check if the temp dot size, that is now the temp is formed, if it is greater. Okay, if it is greater than the result, the previous result, then simply we will store the, if it is not, then simply we will return the same thing, then we will return the this cache I previous index, that is result. Okay, so simply we will return the result, and this is the basically this brute force solution. Okay, so simply it will check for every basically every number, and it will give the result. Basically we can memorize the we can more optimize this by removing this previous. Okay, we can simply check for I, but why we are removing this previous, why we don't need previous. Basically we can simply, basically what we are doing, we can simply assign the first index every time. Okay, then we will simply move forward. Okay, so simply if I give you that solution also, let's just remove this and we will see in the Leetcode. I will explain you that solution, okay, also. So let's just make it, so let's just make it small. Okay, so simply after, basically this is the solution after, basically more optimized way. Okay, so if you see that here also cache size is small. Okay, at previous there were basically no, that's same. Okay, so simply here the main thing is in this DFS. Okay, so here we have removed the previous. Okay, so simply first we will store the nums I. Okay, simply we will first store the nums I in the result array without basically storing the previous values. Okay, so simply, and then we are simply looping through the every element. Okay, then from I plus 1, and we are checking if the condition, if this is divisible, then we will simply store it in, and we are then moving for the next iteration. Okay, basically recursively check. Then we will insert this in the temp, and we will check simply if it is greater than the result size that is formed, then simply we will store it. Okay, so simply we will return it. Because why we are not using this previous, because in this previous we are basically checking every time. Okay, so we don't need previous. Okay, for every that is this integer. Okay, so simply we are checking, and in this also that is in this main function, we will simply loop out for, then we will check, because we can't return from 0. Okay, we can't start this DFS from 0 because here previous is not there. Why with 0? Because answer could be from here also. Okay, if here it was not 1 or equal to 3, then simply the answer would be here. So simply we have to start the recursive solution from every that is index. Okay, so simply that's why in main function also we have written the for loop, and then we are checking for every I to n in this DFS. Okay, we are starting this recursive solution for every. Then we are simply checking if temp dot size, the previous size is smaller and new size is greater, then simply we will return the answer new. Okay, simply this is the solution, more optimized. Okay, if then we will check for the next DP solution. Okay, that's the simply iterative solution. This is same. Okay, we just, you know that if you have learned the DP, you know that we just remove the recursive things and we just add the DP solution. Okay, so let's just take the bottom approach. Okay, so one thing is, you know that in DP we always start from the last. Okay, so simply this is the bottom up approach. If I just tell you the code. Okay, so simply what we are doing, first we are sorting, and then we are taking this DPR and initialize with the n. Okay, that is the last value. Okay, you see from here that is we are getting 45. Okay, at this. Okay, then we are checking for last, that is 45 is divisible by 15. Okay, yeah, then we will simply store these two. Then we will check for 5 to 15 and 45 both. If it is divisible by 15, then we will simply store these three, then in next index. Then we will check for this. Okay, it is not divisible, then we will simply not include this. Okay, but, and then we'll simply at previous index this was 3. Okay, then we'll simply index new 2. Okay, then we'll simply check for 1 divided by 2, then this will be stored, and then we'll check for every, okay, these 2. Okay, then simply these 4 will give the answer. Okay, so simply if I basically see explain you the code, then we have checked the answer, taken the result value, and then DP. Then for we are checking the from the last. Okay, first we will insert the last. Okay, because you know that we have to just insert the last. Okay, then we simply check for every inside. Okay, like we have taken this, then we will check for every. Okay, then simply we will check the condition, then simply we take the temporary. Okay, and then same thing, the temporary we have taken. Okay, then simply we will insert the, then we will simply check if the size is greater than the TP dot, where we were checking result dot size, and simply we will store this. Okay, so it will give the result. Okay, basically these are the code. I will give you this TP solution in the Leetcode also. Okay, so that's it. Okay, so you can see the code basically, the same code that is here written. Basically it is written in structured way here. The same code you can submit it basically. It's accepted. Basically its time complexity is around big O of n square because we are using two loop, and it's like the space complexity is like big O of n because we are using TP array.